All right. Example number 8,000 of combining rational expressions. This is a good one. This is a good one for a couple of reasons, right? A couple of things can happen here. So when we look at the denominators, we want to see if we need a common denominator. Right now they obviously are not common. They don't have all the same parts. They have some, but not all. As far as factoring this has already been factored. Factoring doesn't mean distribute. Factoring means undistribute, right? Divide out all the pieces. Don't multiply to make it bigger. So we're factoring the denominator over here. We get the difference of squares, which factors down into conjugates. Now on the top we have a 9. Over here we have -6. And when you look at these denominators as they're broken down into their parts, this is the first time where it hasn't been the same. This is the first time where, you know, one is not completely contained in the other. I have like a mix and match, if you will. Like this has an x minus 2. Oh, so does this. But this has an x plus 2. So I'm going to need one of those over here. And this has an x, which this one doesn't. So I'm going to need one of those over here. So I'm going to take this x and multiply it over here. And I'm going to take this x plus 2 that is in that denominator, and I'm going to bring it over here. Right? Now we have all of the same parts in our denominator. So I have 9, sorry, a little too far. Sorry. Stop it. What's happening? There. So I got 9x over x times x minus 2 times x plus 2. Now over here, remember what we talked about with this minus sign? Right? I'm going to distribute the 6 into these two terms, into that binomial. But when I write this, I'm going to write it as the opposite of that, right? So when I have over here, I can change this minus to a plus. I can change this to addition, as long as this becomes negative 6x and the 12 becomes negative 12. Subtraction is the same as adding a negative. Now you could have left that minus sign there, right? You either have this as your numerator or you left that negative sign there and you have 6x plus 12. Either one of those is right, as long as when you combine these numerators, you do it properly with their opposites. So we write our denominator, and then finally when we try to get these things together, man, smart board, I don't like you. We have 9x minus 6x minus 12 over x minus 2, x plus 2. We can combine our terms here. 9x minus 6x is 3x minus 12 over x minus 2, x plus 2. Now I'll say this about this problem. Anything strike you about it? You notice anything? I mean, you could factor the numerator, right? I'm not saying you have to, but I will tell you that, like, you never know what MathXL is going to say. MathXL may say leave your answer in its factored form. Technically, you can still factor a 3 away from the two terms up here. It's not going to give you something you can cancel. If you notice, if you do factor a 3 out of the numerator, you have x minus 4. That's not one of these terms down here. And I know I'm repeating myself over and over and over again, but rational expressions, rational functions, polynomial functions, trigonometric proofs, trigonometric identities, okay? Conic sections. We're going to want all of this factored form to identify holes in the graph, asymptotes, things that can cancel, conjugates. It's so important that we get comfortable factoring and writing our rational expressions in factored form. Okay, now nothing cancels, but having it written like this is a good idea. We're going to need to find the zeros of the numerator. Just trust me. When you need to find the zeros of the numerator, it's easier when it's factored. All right? So, there you have it. Fiend.